Hi friends, and welcome to another fun video. Today I'll expand on my previous video where I created a parametric box girder in the classic family environment. This time I'll introduce the option to vary the cross-section height. First, start by opening a new family template. We'll be using a generic template as our host family. This template will contain all the nested 2D profiles we need. Since the 2D parametric family I created in the last video is already created, I'll be reusing it here rather than starting from scratch. For this project, we'll need a total of 4 profiles, 2 for the solid geometry, to achieve different cross-section shapes at the start and end of the sweep in the parent family, and 2 for the void geometry. Note that we need separate void profiles to avoid errors when sweeping profiles with holes. Go ahead and save these metric profiles before loading them into the host family. Nesting in Revit allows us to place families within other families in order to display their combined geometries and make them behave like a single unit within a project. There are many use cases for nesting Revit content, such as the use of repeated components or parametric elements in an array. Alright, our 4 metric families have been loaded into our host family as nested families or nested components, as you can see in the project browser under the families header. Currently, the end user can't access the 2D nested profile parameters when the parent family is loaded into the main Revit project. To make these parameters accessible, first I need to create them again in the host family. So setting up our parameters using the same name as in the metric families. The main difference is that I'll be using 2 separate height parameters, height 1 and height 2, to represent the differences between profile 1 and profile 2. Although we could introduce 2 different width parameters as well, let's keep this example simple. Also need to type in some numerical values, or there will be an error when linking them to nested families. In the last video, I used the sweep tool to create our box girder bridge with a consistent cross-section that followed a line by moving or sweeping a 2D profile along a path. In this video, I will use swept blend, a tool similar to a sweep but with one key difference. It allows you to transition between 2 different 2D profiles along a path. This makes it ideal for creating elements that need to morph from one shape to another, such as tapered beams, curved ramps, or other custom forms with variable cross-sections, or a box girder with varying heights. The maybe not so intuitive part is that I will need to first create the solid geometry, and then I will need to create the void geometry in 2 different instances. If not, I will get an error trying to sweep everything. To use the swept blend tool, I first need to either create or select a path. I'll create the path and align its endpoint with the reference line to ensure our length parameter functions correctly. Then I will select profile 1, which in this case is void profile 1, and then I will select profile 2, which is void profile 2. Now we need to connect the parameters from the nested family to the host family. Go to the project browser, find the nested family under families, and right-click. The parameters on the screen belong to the nested family. On the right side, there is a tiny little button that says Associate. Press this and link the correct nested parameter to the parameter in the host family. Do this for all the parameters and all our nested families. So working with nested families can be tricky, and it's easy to make mistakes in this process. I'll walk through how it works. First, open a new family that will work as the main family, the host family, or the parent family. Then we load in the nested family or families, making it a family within a family. Further, create matching parameters in the host family that correspond to the parameters we want the end user to access from the nested family. Type in numerical values in the parameters. Connect the parameters in the host family with the parameters in the nested families. Let's do some flexing, changing parameter values to ensure the model behaves as intended. Flexing lets you catch potential issues early on, preventing frustration at the end of creating a complex family. By testing and checking each step, you can spot and resolve problems before they become major obstacles. I have not been flexing this family regularly, but that is because this family is not the most complicated one. Imagine having triple the amount of parameters and reference planes, then flexing regularly would be more important. So, I have loaded the varying straight box girder family into the main project where my original box girder was already placed, are now going to match the parameters from the existing box girder with the new one, except the height 2 parameters, creating a bridge with a varying cross-section. And that concludes this tutorial. Be sure to like and subscribe for more fun videos.